Hi, this is Alex from devstories.eu. PySpark Fundamentals, Episode 9 of 21. Garbage in, garbage out. But what do you do when your garbage dataset is hundreds of terabytes in size and you cannot manually inspect a single row? You need a systematic way to sanitize it at scale. That is exactly what we covered today in Junction, cleaning dirty data. The first step in cleaning is usually standardizing your schema. You will often receive raw files with spaces, special characters, or typos in the headers. Use the method called withColumnRenamed. You simply pass it the old string name and the desired new string name. If you have several columns to fix, you chain this method sequentially for each column before you apply any complex transformations downstream. Before removing bad data, we must clear up a frequent confusion regarding null and NaN in PySpark. Null means a data point is missing entirely. NaN stands for not a number, which represents an undefined mathematical result, such as dividing 0 by 0. In pure Python, these require separate handling. However, PySpark groups them together for convenience. When you use the DataFrame NA functions, Spark evaluates NaN values as nulls for the purpose of dropping or filling. To eliminate rows with missing values, you use the na.drop method. Calling this function completely empty drops any row containing a null or NaN in any single column. This approach is highly destructive on wide datasets. A single missing value in an optional metadata column will wipe out a row of otherwise perfect transaction data. To prevent this, pass a list of column names to the subset parameter. PySpark will then evaluate only those specific critical columns when deciding whether to drop the row. Dropping rows is not always permitted by business rules. Often, you must replace missing values with safe defaults. You accomplish this using na.fill. While you can pass a single value to fill all columns, the superior approach is passing a dictionary. The dictionary keys represent the specific column names, and the values represent your chosen replacements. This pattern allows you to fill a missing numeric metric with a 0, while simultaneously replacing a missing category with a text string like unknown. Doing this via a dictionary executes in a single pass, which is highly efficient. Finally, your data might be fully populated but still invalid. Outliers and physically impossible values require logical filtering. You isolate good data using the where method to keep only the rows that satisfy a specific condition. For numeric or date boundaries, the between method is your best tool. You select your column, call between, and provide the lower and upper limits. This replaces verbose greater than and less than logic, making your code easier to read. Any row falling outside those limits is filtered out of the resulting data frame. Here is the key insight. Order matters heavily when cleaning at scale. Always rename columns first to lock in your schema. Drop or fill missing values next to stabilize your data types, and filter outliers last only when you know the underlying data is structurally sound. That is all for this one. Thanks for listening and keep building.